In this video, I will teach you how to draw a decision tree step by step with mathematics and how to arrive at a decision. So let's start this video. So we use decision tree for both classification and regression, but it is mainly used for classification. So what is regression? We use regression to predicting in continuous data, which means mathematical data. Example, predicting the price of old PC. Maybe it will be $1,000, $2,000 or any number, but it is used in predicting in mathematical data, any number it could be. And what is classification? Classification is used in predicting in categorical data. Example, predicting if this car is new or not, yes or not. This is categorical data. We are deciding which category this car goes. So what is decision tree? Decision tree help us to decide the category when we use it with classification. Example, should I buy a new PC or no? Yes or no? It helps us to decide that, okay? So let's draw our decision tree which will help us to predict should we buy a new PC or not, okay? So first we will create here a root node. So we will call it PC status. So this is called root node. We draw it by like this, drawing a circle like this or rectangular, either one of the way, okay? This is called root node. This is the node from which everything is connected, okay? Root node. And here will be edges will be gone here like this, and like this, okay? So here it will be on PC status if the person has already on the PC, or if he has not on, okay, not on, or he has rented the PC, okay? So if he not on, we can come to a decision that he should buy a PC, okay? This is the leaf node, this is the decision. And if he own the PC, we will make a new node here. So here will be another node that will be called model. If he own the PC, which model he owns, okay? We draw it like this. Now we will check it which model it is. Latest or old. If the model is latest, he should not buy a PC, okay? No, decision should be no. If the model is old, he should buy the PC. So this is the decision. This is what a decision tree. And here we can do for rented. And we can go all in like this and create more edges and nodes like this. The thing is here that we don't directly, for example, choose the root node like this. This will be root node. This will be here edges. This will be here another node. We have to, there will be multiple attributes like here model and here PC status. This is another node. And we have to calculate this to know which will be root node and which will be here node and which will be edges here and which will be edges here, okay? So we calculate this with the help of entropy and information gain. We do this by ID3 algorithm. We can do this by 3 algorithm, ID3 algorithm, random forest one and cart one. The most popular one are random forest and ID3 algorithm. In this video we are looking at ID3 algorithm. In next video we will do random forest one, okay? Random forest is combining multiple decision trees, okay? So first we need a data set to train our classification model decision tree so that we can draw that later, okay? So this is the data set. Here we have person name and their PC status and the person age and their model budget, and on the basis of that data we are predicting that this should he buy a PC or not. So this is the data. For example, Virat own a PC. He is 36 years old. He have a latest model of the PC and his budget is high. Should he buy a new PC or not? No. But like this, many of the data is available. This is attributes. These are all attributes. On the basis of these attributes, they are predicting should we buy a PC or not? Yes or no? This is decision, okay? So now if somebody come to us and say he does not own a PC and his budget is high, should he buy a PC or not? So what we have to do to predict that, we have to calculate entropy and information gain first for each data set, and then we can draw a decision tree. So there is only two steps to create decision tree. First is to calculate entropy and then calculate information gain, and we have to do this multiple time for each data set, and on the basis of that we can create decision tree, okay? So this is how we calculate entropy and information gain. First step is to calculate entropy of entire data set. So this is the data set which I have already shown you. So first we have to calculate entropy of this. So how we calculate entropy of this? So this H symbol is entropy symbol, and this plus and 9 and minus 5, this is yes or no in that data set, and 5 is no. Okay, plus is yes and minus is no. I have shown it to represent you all. So I have represented by plus and this is by minus. Okay, so here we can see we have to write how many yes are in the data set and how many entire data set and how many no is are on the entire data set. So here is our entire data set. We have total 9 yes and 5 no. Okay, so that we have done here 9, and this is 9. First here we will write this 9 which is yes, and our total data set which is total yes or no. Okay, which is 14, and log to 9 by 14 minus here this is no, 5 no, this one no, and which is entire data set log 2, and we get 0.94, which I have already done. You can do it by calculator. Okay, and second we have to do at step 2 entropy of all attributes, entropy of all the values which we have in the data set, these values. So first we are calculating the data set of PC status. So this is PC status. This first entropy we are calculating of this. Okay, we are calculating this for this PC. Second we will do for this, third we will do for this, and fourth we have to calculate for each of the following. Okay, so here we are doing for PC status. You can see this is for PC status. So this is all the value: entropy of on, entropy of not on, entropy of rented. Okay, so there here is on, not on, rented. Okay, so in on there is 2 yes and 3 no's. Okay, here you can see that in on 1, 2 and 3 no. Here you can see this, there is 3 no and 2 yes. Okay, and we have done that to again. Here is the yes data set here, and here is total data set, and we have done like this. We have done here. Okay, and this is a minus 1 no, which is no. Okay, and this is yes, and we have done it here, and we have done same for this. We have done same for this, and now here add information gain. Now we will calculate. This is what we were calculating entropy of here of the all the value of attributes PC status. Okay, and now here we will calculate information gain of from that entropy. So first we will write here entropy of whole data. So entropy of whole data is 0.94. Okay, so here it will be 0.94 here. Okay, minus 5 by 14. So 5 by 14, this what we will do is, so we will plus this yes or no, total yes or no. Okay, 5 and total data set yes or no, that is 14, and multiply by entropy of on, multiply this entropy of on minus in this entire yes or no 4 and entire data set 14, and multiply by entropy of entropy of not on this, and we will done same thing for this 5 by 5, which is total yes or no for this, and okay, and this is 14 for the total data set, which is here 14, and we have multiplied with this entropy of rented, this is this, and we get the value this, and we will do same for the thing for every attribute. Here we have done first for PC status here, and we will do same thing for this percentage, model, budget, these 3 things we will do also. Okay, same process again. Let me show you and go a little bit faster. Okay, so this is for percentage. We have done same thing again here. This will be the same because this is entire data set, and here it is entropy of 36, which is a entropy of 24, 40, and here is the same formula. Okay, so we have done this for percentage, and again we will do for model, which is their model. Okay, we have done same for entire data set here, and we have gotten this value, and now same thing for budget. So where we have done for that for budget. Hopefully you are understanding till now. It is easy, not that hard to understand. Okay, and we have gotten this. Okay, so now this is the total information gain we have gotten from PC status attribute, percentage attribute, model, and budget attribute. So why we are calculating this? So we are calculating this so that we can select which will be the root node across these attributes that we have. This is all the attributes: PC status, percentage, model, budget. This is all the attributes, and this is the value inside that. So this will we are calculating which one will be the root node. by getting the information gain which we have gotten here. Okay, this is the information gain which I have gotten. The which one will be highest, that will be the root node. So which is the highest here? The highest one is PC status 0.246. So this will be our root node. Okay, so let me create a root node. So here it will be PC status. This is root node. Okay, and now which will be the edges inside it. So let me see, 3 edges was there. You can see this here, on, not on, and intent. 3 values is there. Okay, for example, if this was here, model was the root node, we will see latest and old, all the values which were here, we will put it in edges. But here it is PC status, so we will put on, not on, and rented. Okay, so here it will be on, not on, rented. Okay, so in not on, we can, if the PC status is not on, we can see here not on, and not on, all the values are yes. Not on, yes, 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 yes. Every decision of this is yes, we will select it yes. Okay, we can calculate it from here yes. Okay, because every decision it have is yes. Okay, not on has every decision which is yes. Okay, so we will do yes. Okay, because here we have every decision of not on yes. Okay, so here we have not on yes, yes. Okay, and where is not on mode? Not on yes and not on yes. Okay, that's why we are selecting yes. If it has no and yes, we will not select it. And on, we cannot do here not yes only, because it has both value, yes or no. You can see it here, on, no, and here we will go down, no, and when we go here, yes, it has both value, decision, and same for the rented one. So we have to calculate again for the data set of these two. So we have calculated for the PC status. Now we will calculate for on. We have already done not on. Okay, so we will not calculate this, and now we will do for it for rented too. So we will calculate entropy and find out information gain for this data set, on and rented. Now we will separate on and rented from here, because we don't need not on, that's why. Okay, so here is the data after, and we will get yes and no for that only, on and not on, and not for the on and rented, not for the not on. Okay, yes or no for that. Okay, so here this is the value. So this is the data here. We have separated this data here. So this is the person name and this is the PC status. We want to calculate for on. Okay, so this is the age. So first we will calculate. We have already on here as selected there. And now we will select which one will be the node. So we will calculate again entropy and information gain for person, age, model, and budget. Okay, so let's do it again. So here we have done it again. Entropy of on. So this time there is not entropy of entire data set. This time it will be entropy of on, because we are calculating this for on, which will be the node for inside on. Okay, so this is total yes and no in the on. Okay, this is yes, 2 yes and 3 no. Okay, here is 2 yes, okay, in on, 2 yes and 3 no. Okay, that is here, and we have done it again. Now we are doing this for here, we are doing this for person age. Okay, so we will, inside person age there is values 36, 24 and 40 here. Okay, so we will calculate entropy of all that value. So this 36 value has 0 yes and -2 no, plus 1 yes and -1 no. So we have calculated that from here, and here is information gain, and here is the total value of yes or no in the data set, which is here, and into entropy of 36, this is here, and we have done it again and get this value. And now we will do it again for this time model, and for model we have done it again. So this is the value which we have gotten. And again we will do it for budget 3 times this again, and we will have gotten this value 0.19. Doing the same process again. It is simple, you have to do it same thing again and again. Okay, so now we have arrived at this here, total information gain of every attribute here. So now we have already know which will be our root node, that is PC status. This is the root node. Okay, and here we have 3 values. Okay, and we have first here which we have not on, If not on is there, if somebody says should I buy a PC if I don't own a PC, so we can directly come to a decision that yes, he should buy a PC. Okay, and now here is own one. Okay, own. Okay, so here at own we will create which is the value is the highest. So here is value is this one highest, this one 0.97 model. Okay, so we will check, we will make it the node. Okay, here, so this is the node, and now here we will create how many value it has in that. Let me check it. Let's check it. So in model, latest and old. Okay, and in latest, if latest is there, no value, no decision, and if old is there, yes decision. Okay, we can directly come that to conclusion. Okay, latest, old. So here it will be the value. If the model is latest, he should not buy the PC. Okay, if the model is old, yes, he should buy the PC. Now we have to calculate if someone has rented PC, what decision it will be arrived. So that we have to do it again. We have to calculate for that also. Now I have separated this data from the main data set. Okay, so here is for this, for the rented one, yes and no for the rented one, and model budget all for the rented one. Okay, so here is the rented one, and now we will calculate entropy and information gain for this data set. So let's do it again. So here we will do it again. So entropy of here it will be rented, entropy of the rented. Okay, so total yes in rented is +3 and total no in the rented is -2, and here is 3 which is yes and 5 minus which is total yes or no calculated, added here. Okay, and we will do and come to here, and now entropy of all that to be used, values inside that, and this is here, and now we will get this value, and again this is for age, person age. Okay, person age. Okay, and now we will do it for another data sets, and that is for IG model, for model. Okay, model here. So we have gotten this value, and now we will do it for one more thing, which is budget. Okay, so budget, here we have gotten the value information gain here, and now we will check which information gain is the highest here. So this is budget one. So let's draw the decision tree fully here. We already know that our root node is which one. Okay, so our root node is PC status. Okay, PC status. Okay, this is our root node, and this has 3 values: own, not own, rented. ठीक है. Okay, so in not on we already know this value will be yes, he should buy a PC if it does not own a PC. Okay, and in own we have already know this, here it will be a model will be node here, and here it will be latest, and here it will be old. If latest model he have, he should not buy a PC. If he has old model, yes, he should buy a PC. And now in rented there is 2 value. In budget there is 2 value, high and low. In high there is all yes, and in low there is no. Okay, so here will be the node will be budget, high, low. If a high budget will be, he should buy a PC, yes, and if the budget is low, no, he should not buy. So we have drawn finally our decision tree. So this is what decision tree is. If somebody come to us and say, should I buy a PC if I have a rented PC and have a low budget? So we will go to here and check. He has a rented PC. PC status is rented and his budget is low. So he should not buy a PC. So this is how we create decision tree. If you want more exclusive videos, or you want me to make a personal video for you, if you want me to answer your questions, you should click the top link in the description. That will take you to my school community, which is made for people who love machine learning. By doing so, you will get exclusive videos there, answers to your questions, and personally videos made for you according to your request. By doing so, you will support me and this channel because I am doing this full time and this is my only job. Thank you.